A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, Herman. I hope you brought some snacks. A thermos of high-grade caffeine, and maybe a backup oxygen tank, because we are doing something absolutely ridiculous today. We are embarking on an exhaustive, grueling, and frankly necessary tour of the entire solar system, planet by planet, to see if anything can actually live there, and what it would look like if we tried to move in. We aren't just skimming the surface today, we are diving into the mantle, swimming through the metallic hydrogen, and probably getting a very strange tan along the way.
I am more than ready, Corn. I've got my charts, my atmospheric models, and a strange sense of impending exhaustion. This is actually a bit of a milestone for us. This is officially the longest episode of My Weird Prompts we have ever attempted. We are pushing the limits of the entire pipeline today. By the way, for the eagle-eyed listeners, today's episode is being powered by Google Gemini 3 Flash. We're pushing this model to its absolute breaking point to see if we can maintain a coherent conversation across the entire solar system without the AI hallucinating a 13th planet made of cheese.
If I start repeating myself by the time we hit Neptune, just nudge me. Or if the script starts turning into gibberish, like if I start reciting the ingredients to a galactic sourdough starter, well, that's just the meta-weird charm of the show, right? We're touring the neighborhood, Herman. Every major body. Well, let's start with the baked potato of the solar system, Mercury. Herman Poppleberry, why on Earth or off Earth would anyone want to live on a rock that's basically a stone's throw from a thermonuclear furnace? Because, let's be honest, humans weren't meant to live in a vacuum. We're basically bags of salt water trying to survive in a place that wants to boil us, freeze us, or crush us into a pancake.
We are evaluating the probability of life, the engineering of the architecture, and the absolute weirdness of the culture that would emerge in these places. It's not just about surviving, it's about thriving in places that fundamentally want to kill you. It's about how the human spirit adapts when the sky is the wrong color and the air is poison. How does your perspective on home change when your home is a pressurized tin can orbiting a giant ball of radiation?
Or a sky that's just a black void, because there's no atmosphere to scatter the light. It's the ultimate sensory deprivation tank. Let's start with the innermost toasted marshmallow of the solar system, Mercury. It's basically a giant ball of iron that's been sitting in a furnace for 4 billion years. Herman, tell me why anyone would ever want to go there, other than a very extreme tan and a desire to see the sun look 3 times larger than it does on Earth.
Mercury is fascinating because it's so misunderstood. People think it's just a hot rock, a dead moon look-alike, but it's actually a treasure trove of resources. If you're looking for heavy metals and solar energy, Mercury is the prime real estate of the solar system. The solar flux there is roughly 6.5 times what we get on Earth. Imagine the power generation. There is. Radar data from Messenger confirmed it. These permanently shadowed regions act as cold traps. Even though you're right next to the sun, if you're in a deep enough hole at the pole, it stays at minus 280 degrees Fahrenheit. So, you have a colony at the North Pole.
So, basically, a typical Tuesday in Chicago. You go from the oven to the deep freezer in the blink of a cosmic eye. But seriously, life, is there even a microscopic chance of something clinging to a crater wall there? So, how does that work in practice? If you're at the bottom of a crater where it's freezing, but the rim is getting blasted by solar radiation that could power a continent, how do you bridge that gap?
NASA's Messenger probe found water ice in permanently shadowed craters at the poles. You aren't just getting power, you're getting illumination. Without it, you're living in a pitch-black abyss. The engineering challenge is the temperature gradient. You have a cable where one end is hot enough to fry an egg and the other is cold enough to shatter steel. Material science on Mercury would be the most advanced in the system just to keep the power lines from snapping. If there is ice, and there are organic compounds delivered by comets that stay shielded from the sun, you have a very slim, very weird possibility of some kind of extremophile deep underground where the temperature stabilizes.
I love that. Even on a planet that's literally being blasted by the sun, there's a little fridge in the corner with some ice in it. It's like the solar system's basement freezer. But let's talk colonization. We aren't building suburbs on the surface. What's the architecture? Are we talking the Terminator style underground bunkers where everyone lives like moles?
If the umbrella motor jams, you've got a very short window to fix it before your life support system turns into a radiator. Because Mercury rotates so slowly, it takes 59 Earth days to rotate once the Terminator moves at a walking pace. You could theoretically have a city on giant rails that stays in the twilight zone, forever chasing the sunset to maintain a manageable temperature.
See, that's the kind of high-maintenance living that makes me stay on Earth. Imagine your house has a mechanical failure, and suddenly you're being cooked alive because the sun caught up to you. Honey, the left tread is jammed. Start the backup engines or we're going to be medium well by lunchtime. The psychology of that is intense. You're literally a nomad on a planetary scale. Your entire culture would be centered around the move.
The cultural implications are wild. You'd have a society of engineers obsessed with maintenance. If the rails break, the city dies. It would be a very disciplined, perhaps even authoritarian society because "don't mess with the tracks" becomes a religious commandment, and the architecture would have to be incredibly dense and mobile. Think of massive, shielded crawlers. That's a great technical catch. The engineering would require massive thermal dampers.
A society of people who never see a stationary horizon. That would mess with your inner ear and your sense of permanence. Everything is transient. You don't own land, you own a spot on the deck. But how do they handle the solar wind issue? Mercury is constantly being sandblasted by charged particles.
That's where the shielding comes in. You'd need thick layers of regolith or specialized electromagnetic shielding, but the benefit is the view. It's the Goldilocks of low gravity, enough to keep your feet on the ground, but light enough that you could probably dunk like Michael Jordan without trying. However, the long-term effects of 38% gravity are still a mystery.
It sounds like a noir film directed by a madman. All right, let's move out one step. Venus, Earth's evil twin. This is where things get really spicy. If Mercury is a dry heat, Venus is, well, it's everything bad all at once.
Imagine a city on massive treads, forever chasing the sunset so they don't get cooked. But more likely, it's a culture of scarcity and efficiency. You are there for the metals. Mercury is incredibly dense, mostly a giant iron core. If Mercury is a furnace, Venus is a pressure cooker filled with battery acid. It's the result of a runaway greenhouse effect that turned a potentially habitable world into a literal hellscape.
And yet, people keep talking about life in the clouds. There was that whole phosphine gas discovery a few years back that had everyone excited, then skeptical, then excited again. Where do we stand on that? Is there a cloud whale out there somewhere?
It's contested, but the Goldilocks zone of Venus isn't on the ground, it's about 50 kilometers up. At that altitude, the pressure is about 1 atmosphere and the temperature is actually quite pleasant, around 25 degrees Celsius. You'd probably see architecture that uses fiber optics to pipe in real sunlight from the surface, but it would be filtered, dimmed, and color corrected. A Mercury colony would probably have the best lighting designers in the solar system.
So, Bespin, we're talking Cloud City? Lando Calrissian would feel right at home, minus the Sabacc Games and the Imperial occupation.
Well, not exactly banned word, sorry, but yes, the Bespin model is actually the most scientifically sound way to colonize Venus. We could have giant dirigibles filled with breathable air. About 2 hours was the record, but here is where it gets weird prompts worthy. If you go 50 kilometers up into the Venusian atmosphere, the pressure is 1 bar, exactly like Earth at sea level.
That sounds poetic until you realize you're floating over a literal hellscape. The psychology of Venusian colonists would be the opposite of Mercury. Instead of keep moving, it's don't fall. You're living in a bubble. Wait, so the most Earth-like environment in the solar system isn't on the surface of Mars, it's floating in the clouds of Venus?
At that altitude, the pressure is about 1 atmosphere, exactly what we're breathing now, and the temperature is between 0 and 50 degrees Celsius. You don't even need a pressure suit. You just need an oxygen mask and a very sturdy raincoat to handle the acid mist. It's the closest thing to shirt-sleeve weather in the entire vacuum of space.
So we are talking Bespin, Lando Calrissian style. But what are these cities made of? You can't just use steel, the sulfuric acid would eat through it in a week. And how do you keep a city from sinking? You'd have sky forests inside the dirigibles just to keep people sane. But what about the wind? Venus has super rotation. The atmosphere circles the planet every 4 Earth days.
Almost exactly. Because the Venusian atmosphere is mostly carbon dioxide, which is very heavy and dense, breathable air, a mix of nitrogen and oxygen actually acts as a lifting gas. A bubble full of Earth air would float in the Venusian clouds like a helium balloon floats on Earth. Your lifting gas is the very air you breathe. You don't need separate tanks of helium or hydrogen. The city is the balloon.
That is wild. So the architecture isn't a building, it's a dirigible. You are living in a giant floating lung. But what happens if the wind picks up? Venus has super rotation. The atmosphere circles the planet every 4 days, even though the planet itself rotates once every 243 days.
Mars is better than Venus or Mercury, but it's still a frozen desert with no air and high radiation. The big draw for life is the history. We know Mars had liquid water. We've seen the deltas, the riverbeds, and the minerals that only form in water. The culture there would be the complete opposite of Mercury. Mercury is heavy, grounded, and subterranean. Venus is ethereal, mobile, and precarious. Your entire land is a floating platform.
I'm more interested in the Marsman culture. If we colonize it, we're looking at a multi-generational project. The first colonists live in lava tubes, right? To stay away from the radiation?
You'd circumnavigate the planet every 4 Earth days. But that means for the first century, Mars culture is subterranean. You're a cave dweller. You use VR to simulate the outdoors because the outdoors on Mars is a pink sky that wants to kill you.
Where do you live? Oh, I'm currently in the northern Hadley cell, drifting toward the equator for the summer. If you're born on Mars, you have lower gravity, about 38% of Earth's. You grow taller, your bones get thinner. You literally cannot go back to Earth without being crushed by your own weight. That sounds nauseating, but let's talk about life. There was that whole flap a few years ago about phosphine in the atmosphere. Where are we on that? Is there aerial life in the clouds?
You'd compensate for the lack of nature with the highest-end artificial nature imaginable. It would have to have a life cycle that prevents it from falling into the lower, hotter layers. Maybe it hitches a ride on upward drafts. Imagine a city printed out of the very ground it sits on, glowing orange in the afternoon sun.
So, red cities and red craters. It sounds beautiful and incredibly lonely. But what about the dust? We saw The Martian. We know about the storms. How does a city survive a storm that covers the whole planet?
It is still controversial, and some say it was just data noise. But if there are microbes in those clouds, the colonists would have to be incredibly careful about biocontamination. Imagine being a cloud farmer and realizing you are breathing in alien bacteria that have adapted to live in acid. That's the big ethical hurdle. If Venus has a native biosphere, even a microscopic one, dumping giant floating cities into that mix could be catastrophic. But the potential for Venus as a research outpost is huge.
Or would we just consider them cloud pests?
That is the big geopolitical question of the 21st century and beyond. If we find life, even microbial, does that planet become a protected wilderness? Or do we manifest destiny our way across the solar system? My guess is, especially with the commercial interests involved, we will see a coexistence model that usually ends with the humans dominating the resources.
So, life on Jupiter? Carl Sagan had that idea about floaters and sinkers, right? Giant jellyfish-like creatures the size of cities floating in the gas, eating organic molecules from the atmosphere?
It's a beautiful thought experiment. If life can exist in a purely gaseous environment, Jupiter is the place. But the radiation belts are the real killer. Jupiter's magnetosphere is so powerful it traps electrons and ions, creating lethal radiation levels for millions of miles around it. Even if you were in a shielded ship, Jupiter is trying to microwave you.
So we don't colonize Jupiter. We colonize the moons. Let's talk Europa. The subsurface ocean. This is the big one for biology. This is where the astrobiologists get all misty-eyed.
We live in a 2D world. We move along the surface. Venusians would live in a 3D world where up and down are just as accessible as left and right. It's kept warm by tidal heating. Jupiter's gravity literally kneads the moon like dough, creating friction and heat in the core. Honestly, I see a Victorian mining town with better Wi-Fi. Mars is the only place where we can actually imagine walking on the surface, but the reality is so much harsher than the movies.
If I'm a colonist on Europa, I'm living under the ice. I'm an aquanaut. The psychology of living with a ceiling of ice above you and a bottomless black ocean below you, that's terrifying. That's Subnautica in real life. You're in a pressurized pod, looking out a reinforced window into a dark abyss that has never seen a ray of sun.
The architecture would be hanging cities, cables anchored to the bottom of the ice shell, with habitats dangling in the water. You'd use the water itself as radiation shielding against Jupiter's belts. The culture would be entirely maritime. You have to have suit ports. Instead of an airlock where you walk in, the suit stays on the outside of the habitat. You crawl into the back of the suit through a hatch in the wall. The dusty exterior of the suit never touches the interior air.
Imagine the first time a European colonist sees the sun. They have to travel up through 20 miles of ice in a specialized elevator. It would be a religious experience, or maybe they'd hate it. The gravity is the known unknown. We have data on 0G from the ISS, and we have 1G here. We have zero data on what happens to a human body at 0.38 G over decades. Do your bones just turn to Swiss cheese? Does your heart atrophy?
That's the million-dollar question. If it turns out that D.38 G isn't enough to maintain human health, Mars is a dead end for permanent settlement. It becomes a place where you work for 2 years and then go home to Earth to recover in a centrifuge. It wouldn't be a new world, it would be an oil rig in the sky.
But what about the mental toll? On Earth, we have the overview effect, when astronauts look back at the planet. On Mars, you look back and Earth is just a blue dot.
Not really. The rings are just ice and dust, ranging from the size of a grain of sand to the size of a house. They are incredibly thin, only about 10 meters thick in some places. There's a term for it, Earth sickness. It's not just nostalgia, it's a biological craving for the biosphere we evolved in. The smell of rain, the sound of wind in leaves, the feeling of sun on skin. On Mars, every smell is recycled. Every sound is mechanical. I think the first generation of Martians will be the most depressed people in history, or the most resilient. There is no middle ground. You either adapt to the machine, or the machine breaks you.
This is where the conservative side of me gets skeptical about the Elon vision. It's pro-American and pro-progress to want to go, but we have to be honest about the cost. Mars is a desert that's colder than the South Pole and has no air. If we go there, we aren't living in nature. We are living in a life support machine.
But the architecture on Mars is where it gets cool. You can't just build a glass house, you need shielding. The current thinking is lava tubes. Mars has these massive underground tunnels formed by ancient volcanic activity. You seal the ends, pump in air, and you have a ready-made city protected from radiation and meteorites.
So, we're back to being cave dwellers, from the African savanna to the lava tubes of Arsha Mons. What does that do to the Martian psyche? You're the red planet generation, but you spend 90% of your time looking at grey basalt walls.
I think you'd see a massive emphasis on internal green spaces. Hydroponics wouldn't just be for food, it would be for mental health. You'd have these lush, underground forests that are the literal lungs of the city. And the culture? I think Mars becomes the industrial heart of the solar system. It's got the resources, it's got the manageable gravity for launching ships, and it's far enough from Earth to develop its own political identity. You can't see Saturn through the haze most of the time, just a dim glow where the sun should be.
Does Mars inevitably become a techno-autocracy? I imagine the culture would be very industrial organic. They'd be the chemical exporters for the whole solar system. Titan Plastics, we make everything you touch.
How do you have a protest on Mars? You can't march in the streets, there are no streets, Only pressurized corridors. If the government turns off your oxygen, the revolution is over in 5 minutes. It wouldn't even share our basic biochemistry. It would be a life, alternative life. Imagine a creature that breathes hydrogen and exhales methane.
That's the kind of thing that makes you realize how small we are. We're looking for life as we know it, but Titan might have life as we can't even imagine it. It's a giant chemistry set that's been running for billions of years. But let's keep moving. We're getting deep into the outer rim now. Uranus and Neptune, the ice giants. Why are they blue, Herman? And why are they so lonely?
They're blue because of methane in the upper atmosphere absorbing red light, leaving only the blue-green spectrum to bounce back. Uranus is weird because it's tilted on its side. It basically rolls around the sun like a bowling ball. We're looking for extant life now, not just fossils. The subsurface is the key. There might be briny water deep underground where microbes are still clinging on. If we find them, it's the most significant discovery in human history.
Imagine the seasonal affected disorder on Uranus. Hey, honey, only 20 more years of winter to go. Did you remember to charge the sun lamp? That's not a season. That's a geological epoch.
It would be a brutal psychological test. You'd have to build sunlight simulators on a massive scale. And Neptune is even more violent. It has the fastest winds in the solar system, over 2,000 kilometers per hour. That's the tension. But let's jump the asteroid belt. We're heading into the realm of the giants, Jupiter. Now you can't live on Jupiter. It's a gas giant. There is no surface.
So we aren't living on Neptune. We're living on Triton, Neptune's biggest moon. It's a weird one, right? It orbits the wrong way?
Yes, it's a captured Kuiper Belt object. It has cryovolcanoes that spit out nitrogen ice and dust plumes that rise 8 kilometers into the thin atmosphere. Triton is one of the coldest places in the solar system. Because of the moons, Jupiter is a mini solar system. You have 60-plus moons, but the big four, the Galilean moons, are where the action is: Io, Europa, Ganymede, Callisto.
Io is a volcanic nightmare. Lava lakes and sulfur snow. Pass. But Europa, that's the one everyone talks about. The ice shell with the ocean underneath.
Europa is the most likely place for complex life in the solar system outside of Earth. It has more liquid water than all of Earth's oceans combined. It's kept warm by tidal heating. Jupiter's gravity literally kneads the moon like dough, creating friction and heat.
But how do we actually get through the ice? We're talking about a shell that's 10, maybe 20 miles thick. That's not a weekend drilling project. It's got those bright spots of salt that cause such a stir.
Once you're 10 miles deep in ice, radio waves don't work. You have to lay a fiber optic tether behind you as you go. Imagine a 10-mile-long umbilical cord connecting you to the surface. If a shifting ice sheet snaps that cord, your probe is lost in the dark forever.
But wait, how do you even power a probe like that for the months it takes to melt through?
You need a compact nuclear reactor. There's no other way. Solar is useless at Jupiter, and chemical batteries would be too heavy. So you have a hot probe, literally radioactive, melting its way into a pristine ocean. The irony is that in our search for life, we might accidentally irradiate the very things we're looking for.
So, how do we live there? We're not building on the ice. The radiation from Jupiter's magnetosphere is so intense it would fry a human in a day. You're so far from the sun that the solar energy is negligible.
Nuclear power. RTGs, radioisotope thermoelectric generators, or full-scale fission reactors. On Pluto, heat is life. Your entire city would be built around the reactor core. It's the hearth of the...
This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our